Okay, so the 2 to the 2 case.
Well, so I think we can think about this in that there's only really 3 different places we can put the L that would result in a different case. So I think those places are here, here, and here. And because if you put it any other place you put it, you can rotate it so that it's one of these 3 cases.
All right.
Or flip it. Like if you put it here, you could flip it so that it's this case.
Okay, interesting.
So this means we only really have to look at these 3 positions and find that they all work. Or find a method that makes everything work.
Okay.
Well, what you could do is use the 2 by 2 case for this bottom square and then build like this around that to make this new arrangement.
Okay.
So it looks like if you built like this kind of diagonal structure out, maybe this could be our method, at least for when it's in the corner.
Okay.
So,
And then-
sort of,
I guess when it's over here,
you can do the same thing.
you do the same thing and
You
then
can just do that.
build out the diagonal like that. And then when it's up
You just
here,
rotate it. It's always the same.
Okay, interesting. Now, give me some reactions to this method. This method as we go up to the larger and larger cases.
Well, seems like this could continue to work, just building off of this, the original, or the one before it, and then sort of building around that. You're definitely going to have enough space to keep doing that. You're definitely going to be able to fill the board.
I think one problem is that the yellow square might not be perfectly on or near the diagonal enough for this to work. But we could keep using a 4x4 case to fill up the bottom 4x4 in like an 8x8.
All we need to do is prove that it can be done. So if we follow a specific method every time, we can prove that it works for every level.
Okay, good. So these are both very good observations. One is you could always, although you're not, it's going to get very complicated where the yellow square is going to end up. Especially because here you said there were only 3 potential cases. And rotating and reflecting could help you with that in the 4x4.
Yeah.
It may be that as you get larger values of n for 2 to the n, like the 128 by 128 case, there might be more than 3 places. But you did say then that you could use the idea of that you could always sort of rotate the L square into this bottom corner square, and then use the lower case. So that's a good observation.
So I think something that we could prove that might make our life easier is that when you go up from a 2 to the n by 2 to the n to a 2 to the n plus 1 by 2 to the n plus 1, that the only unique cases where you can put the square in the 2 to the n plus 1 by 2 to the n plus 1 case are in this 2 to the n by 2 to the n square.
Okay.
Like for a 4x4, you could only uniquely put it here in the 2x2. And I think for 4x4 to 8x8, you should be able to only uniquely put it in this 4x4.
Okay. Why do you think that's true?
Well, first you can only these 4 squares are on the edge, the outer edge squares that are unique. So everything else is just a rotation of that or a reflection. And then these 3 squares are the only second edge squares that you could say are unique.
All right.
And then these 2 and then these 1 maybe.
Okay. Can you think of a way of why for going from the 4x4 to the 8x8 that we could always just pick the yellow inside of this lower square?
Well, I mean, you've proved that you can solve the case for the 4x4, and no matter where you
But what if I pick it up here?
You can use this quadrant as the 4x4 case, and you can, no matter where you put it, it'll be inside the 2x2 case, and then you can make the 4x4 case from that.
Okay.
Or you can just simply rotate it down so it's down here.
Yeah, or I can just simply rotate down. Okay, so good. So let's keep talking about ways, now that we're starting to gain some understanding of the problem, how can we use the lower cases to build up to the upper cases?